We now have Dmitry and Imre. We'll be talking some more about RDO Manager. Thank you.
Okay. And hello everyone, and my name is Dmitry, and his name is Imre, so you don't confuse us. We'll be talking about the bare metal provisioning part of the RDO Manager, and just to clarify it a bit before I hand my laptop to Imre. So this RDO Manager thing, or triple, because when I say triple, it's usually mean RDO Manager. When I say RDO Manager, it means triple. It's essentially the same thing. I aim these two things to be as close as possible. So RDO Manager is essentially a distribution of triple in the same sense as RDO is a distribution of OpenStack. Well, at least we try to make it. And its primary goal is not do it on virtual machines. Obviously, its primary goal is to do it bare metals. So we start this with one machine and the cloud, where we install this actual thing, triple or RDO Manager. And it is a small installation of OpenStack on itself for managing bigger installation of production OpenStack. And once you get to this point, and Rain has told you how to, we can use this OpenStack to provision bare metal machines with images of this production OpenStack. And we'll be talking about this bare metal provisioning part because it's the only thing that is essentially different between on-the-cloud OpenStack and OpenStack we're installing. So for us, for the thing we're talking about, bare metals are the same as virtual machines for usual OpenStack. So we're provisioning using Nova, using the same set of APIs, taking images from Glance, using Neutron for networking, etc., etc. And yeah, but there are a lot of small subtle differences in it. And now I'm handing mic, non-existing mic, to Imre to talk about the Ironic project which powers this bare metal provisioning.
Yeah, but first about the agenda. First I will introduce the bare metal services in OpenStack, which is Ironic and Ironic Inspector. Then we will go through the introspection of the deployment workflow after the first few steps, but a pretty simplified version. And then Dmitry will continue with debugging bare metal. So Ironic is the OpenStack bare metal service. It's for managing and deploying bare metal machines. The rationale behind its existence is, from the RDO Manager standpoint, it's pretty simple because we want to deploy a cloud infrastructure on bare metals. But there are other use cases like HPC, Hadoop cluster, or database server, in which case you don't want to pay the virtualization overhead, even if that's like only a couple %. And the third big use case, even if Ironic isn't there yet, is multi-tenancy. But Upstream is working on it. And as for the architecture, it contains a RESTful API service. The RESTful API service is for admins only, because as Dmitry already mentioned, all the features should be accessed by Nova. So the API service is mostly for registering nodes. And the API talks via RPC with the conductor service. And the conductor service is the one which basically does all the job. It contacts the bare metal machines, its BMC, and does all the work. And by doing it via pluggable drivers, so because there are different vendors and there's no generic interface, like there's IPMI, but that's usually just a very limited set of what we want to use. But there are drivers, for example, DelDrex or HPI lows, and by these pluggable drivers, you can use your own machine from different vendors. And of course, it also has a database and a deployment from disk or agent, which I will talk about later. And so As for the pluggable drivers, each driver has to implement different interfaces, which basically how Ironic supports different features. And there are core interfaces which all drivers have to implement, because those are pretty basic ones, like the power for changing its power state, the deploy for deployment, of course, and management for setting or getting the boot device, for example. The standard interfaces are not required, but pretty useful. Like console, you can get usually URL for the console of the bare metal machine. With inspect, you will start the introspection with Ironic Inspector. I will also cover it later on this talk. In RAID service, of course, you can configure RAID devices. And the third group of interfaces, or actually just one interface, the vendor interface, where each vendor can put whatever feature they want on the interface. So for example, there's no interface for BIOS management, but in Ironic, the drag driver contains a specific method for setting the BIOS settings, and of course getting it also. And here's just an example how a driver looks like. This is the Pixie IPMI2 driver. It is pretty limited because of the limitation of IPMI. It just have a power and deploy interface defined here, and some magic with the vendor interface, because we need a mapping between two different vendor interface. And here we are setting the IPMI power class, and this is the three methods you need to define for your own hardware. Just get power state, set power state, and reboot. And it's pretty straightforward, and that's how you implement your own driver. And to understand how Ironic does its work, I will go through the deployment workflow. So first, Ironic, when it receives a deployment command, it will fetch the deploy RAM disk and the overcloud image from glance. And of course, we are talking about RDO Manager use case, so it's not necessarily the overcloud image. You can use any user image. Ironic can deploy whatever you want. And after fetching it, it will prepare the Pixie environment and updates Neutron. So basically, Neutron handles the Pixie environment, and then sets the boot device for the node via the driver interface, whatever driver the node is using, and then reboots the node. And the node will get DHCP'd and loads the RAM disk. Its task is pretty simple, just to expose the local root disk as an iSCSI to Ironic, and then iSCSI basically just DDs the image to the disk and reboots the node. And in case of RDO Manager, it also sets like local boot, so not Pixie all the time. And before talking about the RAM disk, there are different management methods, like in-band and out-of-band. Like out-of-band, when you rely on the features of your BMC, and BMC stands for Baseboard Management Controller. So it comes with your node, and the vendor usually puts useful features there, like for example, the Dell drag cards contain interfaces for RAID management, BIOS management, and stuff like that. But since not everything is available on the BMC card, for example, HP IO doesn't support RAID configuration out of band. We also need in-band management, which means that you run a RAM disk inside the machine, and you do stuff via like normal Linux commands, or like downloading a utility for like HP RAID configuration. And so Ironic Python agent is a solution for doing in-band operation, and it's the new RAM disk in Ironic. And instead of just exposing the root disk via iSCSI. It has many more features, like erasing disk, partition disk, and all these features. And it's easily extendable, and that's basically the new default RAM disk. And as for Ironic Inspector, what it does is collects hardware properties, which is required for scheduling the node. And it has many other features, like setting new IPMI credentials, even if you don't know the original ones. And it processes the hardware properties which was sent back by the RAM disk by these plugins, like RAM discoveries for dealing with error reported by the RAM disk. The scheduler will extract the required attributes for scheduling, so it will update Nova scheduler. Validate interfaces will compare the network interfaces with the one which exists in Ironic and updates them or deletes them accordingly. RAID device is just for out-of-band RAID configuration. When you created a root RAID device, you need to store the root device ID in Ironic, because if you have multiple disks, Ironic needs to know which one needs to be exposed and copied, and the content of the image should be copied too. And extra hardware is also an optional one, because Ironic Inspector and the RAM disk collects like 1,000 facts about the hardware, and for scheduling you only need like 4 or 5, but you can save the extra facts about the hardware in Swift, and that's what the extra hardware is for. And third feature is introspection rules, but before talking about it, let me talk about a different problem. So if you have a different type of hardware, you need to know first the properties of that hardware, and since they are different, you will assign different roles to it. So for example, if you have nodes with high CPU, that will probably go a compute node, or if it has a lot of disk, then it will be a storage node. And this is what Ironic Inspector supports. You can tag the node with these profiles according to different rules. So these introspection rules, you define a set of conditions and actions, and after the RAM disk collects all the data, it will run these rules, and as a result, you will have the nodes tagged by one of these profiles if you set up the rules that way. And this architecture is, there's the Ironic Inspector service. Its API is the same as with Ironic. It's for administrators, and it also contains a callback for the RAM disk. It has a separate DNS mask service because it required a feature which doesn't exist in Neutron yet. So Inspector runs its own DNS mask service and disables access to it via IP table rules. And it also using Inspector RAM disk or agent, the Ironic Python agent. And the introspection workflow is somewhat similar to what you can expect according to the Ironic one. When Ironic Inspector receives a request, then it first validates the node, validates the power credentials, validates its state, the power state, and the deployment state, and then prepares the PIX environment, which I mentioned updates the IP table rules, and then just reboot the nodes, and the nodes get DHCP, then loads the RAM disk, which runs for 10 or 15 minutes while collecting all these 1,000 facts, and it just posts back to Ironic Inspector, which upon receiving it validates the receipt data, as like I already mentioned by the plugins. It compares with Ironic and update the ports, and then just sets its state to ready for deployment. And the deployment workflow, this section will be quite short because I already discussed how most of the stuff done in Ironic and Ironic Inspector, but it consists of 4 stages. first you define your nodes in a configuration file, and then enroll the nodes in Ironic, which basically creates them in the database, and then do the introspection and deploy the cloud. And there's an optional step, which I also mentioned, automated profile tagging with Ironic inspector rules. So this is how your configuration file, you list all your nodes. You define what driver do you want to use. So it's Pixie IPMI tool in this case, which is a pretty generic one. It just uses Pixie and IPMI, which most hardware talks. And then just the power credentials and the MAC address. And with OpenStack Bare Metal import command, you import this file, and the nodes will get registered in Ironic. And then Ironic goes and checks the power credentials and sets the power state. And here's an example of Ironic inspector rules. This is for automated profile tagging. So for example, here you can see a condition. It means that if there's less than 4 gigs of memory, then action is to fail, because that's too low memory for anything. And here's another one. You need to take the conditions and the actions in order. So for example, if it has less than a terabyte local disk, then it will be set to a compute profile, or it has more than 40 gigs, then it will be control profile. And so this is still the optional automated profile tagging step. You import the rule to Ironic inspector, and it's important to do this before inspection, because that's where the rule gets applied. And you start the inspection with the OpenStack Bare Metal introspection command, and this is what we've already discussed when I showed the Ironic inspector workflow. And after it's done, you can check the profiles each node got with the OpenStack overcode profile list. It will just output what each node got in profiles. And this is the last step. You have set everything up, and OpenStack overcloud deploy will just deploy the cloud with Ironic. How I already mentioned the steps in Ironic. So the nodes will get rebooted, Pixie booted, and then the RAM disk will copy the image. And now I will give back the talk to Dmitry, who will talk about how to debug if anything went wrong.
Imre was talking about what can go right. I'll be talking about what can go wrong. But before we do that, maybe we have a short question section on what was already told, just to make sure.
So you mentioned, you mentioned vendor drivers. Which level they fit in? So drivers for
those are in those fits in Ironic. They exist in Ironic, and they basically how you interact with your hardware.
So low-level operations.
Low-level operations, yes. So for example, with the IPMI driver, you issue IPMI commands.
Power on, power off, set boot device, what else? Get boot device, and
there's no.
Such commands like
I
that.
was thinking there's no like high-level driver which will be interacting with existing, I don't know, bare metal, whatever. For example, company has something to deploy bare metal and then just gives metadata to Ironic. No,
not that. It's particularly low-level operations with different types of hardware.
Okay.
Other protocols like IPMI2 or ILO, which has, I think, Wisman, right? Or what do they have?
No, that's Draken.
I think they also have some big XML.
Yeah.
Yeah.
So,
okay.
yeah. Go ahead.
Yeah. You mentioned the Ironic Python inspector. Does it use libOS info project, which is libOS info project is a project that has a catalog of all hardware, virtual hardware that provides this operating system. It's a large database of all you can consider it as metadata, which contains information about different kinds of OSS and virtual hardware, and etc. This was briefly brought up on OpenStack Developers like a while ago, because you're also doing inspection, and do you take advantage of such databases?
Yeah, I didn't quite. I don't think we use it. I didn't quite get what can we use it for. To be honest, is it some toolings that you can use from inside the machine to get information about this machine?
Yeah, you can. You have a guess. So you want to detect what hardware it has, or what it is running, and what else is running inside it. So all of this can be detected by. It has a command line tool that you could use to query a whole lot of information about different kinds of virtual guests.
Oh, why virtual guests? Sorry.
No instance is a virtual guest.
Well, we're talking about bare metal, right? It's a bare metal server that just got RAM disk booted.
Yes.
No virtualization, no nothing, no VPP providers. Does it allow me from within the running code on this bare metal instance to get its hardware information?
Yes, it also has the bare metal detection info. But yeah, you could later on check it out probably if it's
yeah, I'll check it.
that
Please send
much.
me it. Okay.
So, question?
Yes,
The
sure.
benchmarking stuff is still there, or?
Will bring in its... Because,
It means no.
yeah. Yeah, because there was a lot of downstream things that we supported, and as it moved to triple, nearly all parts of introspection were just removed. And then we rebrought them, but not all of them.
Okay.
You know, benchmarking is still not there. That's our target for the next release. But I'll briefly tell you what Fred is referring to. We used to have benchmarking within our inspection RAM disk. So while we're introspecting hardware, we also ran some benchmarks on them, and then we could use like introspection rules. They didn't exist back then, but now we could use introspection rules to, for example, say, okay, well, this machine is suspiciously slow. So we drop it from cloud before we figure out what's wrong. Right? That's kind of the use case, yeah. But that's for the future now.
Is there a link to the Foreman project?
They're not linked in any way. They have some overlap, but they're completely independent. Anything else before we start brain melting? Good. I'll switch to another presentation. Yes. This is just a link to this talk, just in case you want us to check it out later or follow it right now. Bare metal deployment is a complex thing, and it's subject to a lot of various kinds of breakages. So what I'm planning to do now is to provide you some hints what to do when you start with this shiny tuple thing and it doesn't work like you expect or doesn't work at all, and how to approach this thing in general, and how to approach the breakages at the bare metal stages, like inspection and ironing. So what I provided here is how we structure it. Well, of course, check that you are saying that you provided the correct input with quick start script. It probably will be always the case. Next, I'm going to tell you which parts tend to break more often when you do bare metal deployment, particularly as applies to triple or RDO Manager. I want to show you how to figure out which particular part of these 4 deployment parts is actually broken in your particular case. I don't touch introspection, it's a bit easier to figure out. How to figure out where we are, and I will briefly say where to find the logs and how to deal with them, because sometimes it raises this question, and of course, yes, it is. So I have just highlighted the things that I will particularly concentrated on in this talk. I've started with this one already, and I'll continue from the beginning now. Where things break? Introspection. well, first of all, you should always mind node states. Ironic in its database had a field called provisioning state, which essentially says you at which stage of its life cycle this particular node is. So one of the first states to have is called manageable. It's a stage where Ironic has confirmed it is able to talk to this node varied by BMC, but it's still not ready for deployment. And when you do introspection, this state, this is a state that your node should be in. Actually, this long command that you use in triple also works in available state. And available state is the next state for a node. It means this node is ready for deployment. So if you notice some other state, something is probably wrong. Again, with quick start script, it's probably not a big concern, but mind it always. Now, this is interesting part. This is the biggest source of all possible breakages. As Imre already told you, Ironic Inspector requires a separate DNS mask service to serve DHCP requests. And of course, it requires your node to be able to access it. Things that will break you, probably firewall settings. I think we're mostly fine with this, and all the undercloud scripts manage firewall settings pretty well. Mind this thing. I'm constantly encountering a situation where switch configuration is preventing a node from sending DHCP requests or DHCP response from going to this node. If you have several networks where DHCP server is located, mind NIC ordering in BIOS. So, for example, in my lab environment, I have provisioning network where this all magic happens, and I have some big corporate network where they have another DHCP server which can be used for just installing, operating system. So if you put this network card first in the boot order, no introspection for you, sorry. Essentially the same point, but make sure that this network interface actually has PXE enabled. Again, constant source of failures is just not enabled in BIOS. Well, yeah, pretty obvious. If you have two DHCP servers on the same network, all kinds of things can go wrong. This is my favorite one. Mind that iPXE ROM shipped with CentOS 7 is pretty old. It dates back in 2013, and it has all kinds of problems. So if you see that everything is same, but it still doesn't boot for some reason, you may try to grab new iPXE ROM from ipxe.org website. They have it pre-built, or just build it yourself. We're working on fixing this problem distribution-wise, but now it can be a source of problem. Next, scheduling. One more funny thing. So just a reminder, anti-cloud is a cloud. It uses Nova, meaning cloud is Nova, essentially. Ironic is plugged into Nova as a hypervisor. Well, it's not, for virtual machines, it's not a hypervisor you're used to, but that's how we work. Nova treats Ironic as a hypervisor. So it uses typical Nova scheduling, and Nova scheduling doesn't play really well with Ironic. And that's the thing we are trying to fix for a long time, and will be for a long time. So just for now, yeah, the biggest difference, why am I talking about the difference? When you schedule virtual machines, you essentially request a flavor from a hypervisor. So a hypervisor dedicates some part of its resources for your virtual machine. With Bare Metal, you can't really tell it to change its characteristics, right? It has 4 gigs of RAM. You can divide it because it's one big instance. One instance occupies one Bare Metal. And you can make it bigger, of course. Well, you can make it smaller on some hardware, but that's a very, very specific use case. So you have to be sure when you request to deploy a flavor, there is a Bare Metal that completely satisfies your request. Going from it. And I'm talking about number 3, essentially, right? So if you request a flavor, there should be a node that is of these characteristics or better. So more RAM is okay, less RAM, sorry. Now, Nova and Ironic are separate services, so point number 1 here is actually make sure Nova talks to Ironic. If it doesn't, it will silently ignore it. So there won't be a big bang. It will just, hypervisor starts will be empty, and any request result is no valid host found. So mind this. Only logs can uncover this situation, actually. Again, manage node states, only available state, node provisioning state is suitable for deployment. Nothing else. Manageable doesn't work, by the way. This I managed. Capabilities. You probably know about Nova capabilities. I think it's a common thing. But again, we use a couple of capabilities, and capabilities essentially random properties assigned to both flavor and node, and they should match. We use boot option, which tells you to do local boot, so it has value local for triple. And we use profiles, which Imre already told you about. Again, if your flavor requests a profile, for example, compute, there should be a node tagged to this profile compute. Even if everything else matches, but these 2 strings do not match, no luck. One small notice. Nova and Ironic sync in up to 2 minutes. So if you just edit a node, wait a bit before jumping into deploying. Again, our scripts actually handle this situation, but just to make sure you know that. That's not all, that's not all. Now about Ironic itself. There's a nice property of Nova, maybe really nice, but for virtual machines a bit less for us. When Ironic fails to deploy, Nova usually retries, which makes it impossible to easily figure out what went wrong, because it cleans up the Ironic instance, schedules one more, oops, cleans up, schedules one more, oops, and you end up with this error message. So don't be afraid of this. That's what I want to say. Don't be afraid of this. If you see nothing but this happens, Ironic logs have the information. Warning about disk space. Your Ironic sets up PXE environment. This PXE environment contains images. Images should be there. It also converts images, so mind the free space. It's a popular problem on virtual environments when you set up your testing virtual environment and okay, 10 gigs is enough. Then you have 500 megabytes free after installing on the cloud, and Ironic says you, no way. And by the way, you'll get this error message in this case. Because, number 1, BMC. One of the most popular problems, BMC are terrible. All vendors probably, I didn't try every single one of them, but every single I've tried, they're pretty bad. They tend to lock up, they tend to refuse your request, they tend to respond for 2 minutes, 3 minutes, 5 minutes, 10 minutes. For simple, like get boot device, 10 minutes. Wait. So, but essentially the most important thing that you have to be sure is that your credentials are right and the thing is still alive. Need to check, use IPMI tool or vendor specific tool. Drivers, we have mentioned drivers as well. Some hardware is supported by more than one. Typical situation like HP, PXE allow is a specific driver, PXE APMI tool is a generic driver. We tend to prefer vendor specific drivers. They usually have less problems, unless they don't work. This is a rare case really, but I just put it there for people who will go through these slides, figuring out why Ironic says that it doesn't support a driver. Ironic is an HA system. It has a lot of conductors. If none of conductors start, it will say that no conductors support your driver. It's a bit confusing, it just means that conductor didn't start. We are not done yet, deploying process. The same notice apply like for introspection. DHCP should work. There are some drivers that don't require essentially DHCPing, but they are vendor specific, and We don't currently recommend using them with triple, or we don't actively test them. They can be enabled and ironic, of course. You can experiment them. I encourage you to experiment with them if you feel like. Drop by our RC channel if you want help with that. But currently, DHCP and PXE booting, or IPXE rather, is a must. IPXE ROM, again, warning. We're still working on problems with setting up local boot. Sometimes it breaks, sometimes you don't know why. While we're figuring it out, I'll just make sure if you see you have problems with that, you can always remove this boot option capability from flavor and node. And it will no longer set the bootloader, it will pick boot every time your instance comes up. That's how it used to work for running for a long time. That's more tested probably. I wanted to say something else. Okay, I forgot. Now, okay, a bit less boring text, a bit more interesting commands. So, you ended up with a failed deployment. Where do you go? Essentially, it's useful to issue this number of commands. First of all, heat is our orchestration tool. Who doesn't know what heat is? Well, me neither, essentially, but I also don't know, to be honest. But, it's our orchestration tool. It manages the whole boot process stack. Tell Nova to boot this, tell Nova to boot this, tell Puppy to configure this. And that's primary entry point. So you get list of resources and find failed one. I will show you an example, don't worry. Then we go down to Nova, take a look at the list of instances. If you don't have any Nova instances, something probably broke before we even get to this point. If all Nova instances are in perfect condition, they're all active and running, probably something broke after this point while we were configuring over cloud OpenStack with Puppet. So this is a useful thing to split problem into two fields. And this thing shows ironic nodes. Again, they have provisioning state, you can check it. I'll show you examples. Get scared. I essentially told this. When we're checking heat resources, do we have a heat stack? If you don't have a heat stack, you probably didn't start the deployment. Do you have failed resources? And what are their types? I don't know much about heat, sorry. Nova instances. Again, do we have no instances? If no, yeah. What is the state? If state is error, we dive deeper. If state is fine, we go to figuring out what went wrong with Puppet. Checking our nodes. Again, provisioning state is an important field. Check what all nodes are. Available means nothing happened to them, or it means that Nova has retried and cleaned up. Error state, something failed. Manageable states, these nodes won't be using for deployment. Active state, nodes are fine. One thing that people usually don't notice, and I want you to pay some attention to, we have a flag called maintenance. We use this flag to denote this particular ironic node should not generally be touched by ironic because it was taken by an operator for manual intervention. So if this maintenance flag is set, ironic won't deploy this node, won't do some periodic tasks on this node, it essentially just exists and it will react to some API. So if you power it on via ironic API, it will work. But anything else won't. So this is a nice way to mark a node. If you ever want to mark an ironic node as like don't touch, this is what you use. But there is one condition under which ironic can set this flag automatically. And this is when it can't access the node's BMC. So if you see this maintenance flag set on node, and you're completely sure that you didn't do that, and you didn't give your credentials to someone else, that's probably the problem. And this problem is probably what broke. So mind this. Instance UUID is a field that's assigned by Nova. So if you have an active node, it should have this UUID. If you have a node that is not active, not provisioned, having this UUID is a bug. There are race conditions under which it can happen. Because this UUID is cleaned by Nova. if Nova fails to clean it, it will stay on the node, and this node won't be used for provisioning again. It should be cleaned manually if it happens. Well, if all nodes succeeded, then again, probably something went wrong in some other place. Logs. Just brief information of our logs. We usually store them both in journal ETL and in as text files. And I put a couple of helpful commands that I often use to figure out what went wrong with using journal CTL. Just for reference, take a quick look of what it is. Or just access on GitHub later.
Yeah, there's also a flag that I use since today, --, so that kind of, if you know that your errors are, I mean, for libvirt daemon, I often use that because there's tons and tons of errors it throws, so you can libvirt something today if you just
Great.
pass that flag.
I didn't know about that. No, I learned something as
Yeah,
well.
there's plenty of them.
Before I show you examples, very quick examples actually, do you have some very quick questions? Well, good, good. It was scary, right? Okay, I simulated a failed deployment, right? So this is how it starts to look. I do this heat resource list, and I see two failed resources. They're called compute and controller, which means probably failed to deploy. If you see some other resources, like something configuration related, I'm not sure how it's going to be called, but if this happens, it's probably a different problem. How's called Nova list? Well, so you see this error. It's pretty obvious. Controller has failed, compute has failed. We had two nodes deployments, so both has failed. I'm using a bit bad command. I should have used really OpenStack based commands here, but I forgot about that. So bear with me. I used directly Nova command. And this Nova host was found is Nova's favorite error. You see it in 90% cases of bare metal deployment.
In 90% of all fails you get from Nova, no? Just
Yeah. But for bare metal deployment, scheduling is particularly tricky, as I already told. So this is very popular. And it's one of those cases. Either scheduling failed or retries failed. And then you go to Ionic, and everything seems okay at first glance. But what's not okay? Hiding this. The maintenance flag is set to true. So that's what I was telling you, right? We pay attention to these fields. Instance UID, provisioning state, available for deploy, very good. This is not good. This small flag is usually overlooked, but it should not be set to true. And well, that's a hint. Power state is also can be none, really. We have a few types of maintenance reason. You set it yourself when you set maintenance mode, or Ionic set it. And yeah, now we see that sync power state function has failed. And actually I simulated this by setting a wrong password. So, in the middle of deployment. So yeah. Next short example. I know that people are constantly hit by this, so that's why I just brought it here. People have to remove a node from their deployment because BMC broke, because it broke, Hammer has fallen on it, and now they try to delete stack. Well, because they don't know how to recover the situation, they just delete the stack. And you can't delete stack in this condition. Why? Let's figure out. Well, because we can't delete the associated Nova instance. Nova remembers that Ionic node was associated with it, and Ionic remembers this node, but they can no longer clean up the deployment from it. We need to unprovision, we need to clean data from the local disk, and so on and so on. It's not possible. Node is physically removed, it doesn't exist. So what do we see? Nova is failed. One instance is available again, so this first instance and provision successfully, right? Maintenance is false, I've checked. The second instance is still active. Active means provisioned instance on it, but we no longer have power state because there's no longer node. What to do? Now I'm just showing you. What to do in this case. Just, for example, how to work with Ironic API. Make sure maintenance mode is set. It's probably already set by Ironic. Now that you set maintenance mode, Ironic allows you more operations on an active instance. Because when you have an active instance, of course, Ironic prevents you from doing some things that might break. As soon as you set maintenance mode, you are free to remove instance UID and just dissociate it with Nova. And as soon as you do that, you can try to delete your whole stack again. For some reason, you have to repeat this command several times. At least I had when I reproduced it. This concludes the second example. And as to complain part, because I think I didn't complain enough, so you have to do that for me. Let's use it two sources. We have RC channel OpenStack Ironic on Freenode. We are very friendly. We like to chat. We like to help. Come by, ask, complain, ask for help with your experiments. If you're pretty sure you have a bug, again, this is upstream bug tracker. We encourage people to work more with upstream. We are not scary. The scary thing is my presentation really. We are much better. And thank you for your attention. Any questions? We have, I think, 7 minutes. Please. Yes?
This last example, it looks like it should be bug, it should be fixed. Is it in progress or somewhere? Because it's like deleting the node breaks the whole thing.
Well, the reason we don't make it automatically is because that's a dangerous situation, right? Ironic doesn't know why it happened. Ironic can't confirm that we really physically removed the node, or just BMC broke, or network connectivity. So proceeding just silently dropping everything will make operator aware of this dangerous situation that happened. So we do it. That's why we prefer to fail in this situation. Well, it's possible to recover, as you see. I didn't. But if it goes unnoticed, it may fail the next deployment.
But maybe there should be like force, like I want to delete anyway.
That's a good catch and good feature request, actually. I think the only reason we don't have it now is because too many projects are involved, complaints about OpenStack. Hit, Nova, and Ironic all should receive this flag. It's a good feature request, but it's going to take time to implement. Yeah. Where sometimes we talk about, oh, we should have force mode. Does that answer the question?
Yeah.
Anything else? Yes.
So at CERN we have 5,500 hypervisors now. So we tell our customers virtualize, but there are some pockets of resistance, shall we say, some genuine use cases where people want a bare metal machine. Should we look at Ironic to actually provision that for them?
Yes.
Yeah, because we want to then delegate the administration, right? We will have our colleagues from the experiments actually screw that machine over completely. Can we do that safely?
Well, to some extent, depending on the definition of screw. If they try to update firmware,
they are redefining that all the time.
if they try to update firmware to something non-existing that might end up badly, we can prevent root user from, for example, updating firmware on the machine, if it's possible. Or if IPMI2, they do something with BMC using IP metal from within the machine again.
Okay, but if I have a way to purge all that and reset it when they get the machine back eventually?
We're working on that. Okay. And that's one of the features for coming releases, yes.
Because I just want, basically, as a service, infrastructure as a service provider, wash my hands off that machine once I've given it to our experimental colleagues.
Yeah. So what should I tell you? Rackspace company is using Ironic for providing their own metal service, for providing bare metal instances to users. They're pushing really hard on making all these things robust. So it's already pretty cool to have like cleaning, disk cleaning, and something else. And I know HP folks are talking about firmware updates automatically before and after instance is given to a user. So some of the things exist, some not. Stay tuned, draw by our channel. We can.
Yeah, those are mouth-watering features, because now we do everything by hand. So it's extremely painful for us. And the other question goes along those lines. We had a look at Ironic some 2 years ago and found it
Yes.
young.
It didn't work. I know.
Does it work now?
Yes.
Wow,
Can
such
you
great
elaborate on
answer.
that? You can sign that in blood?
Yeah, it works.
Okay.
It's used in the RDO Manager as the provisioning tool.
And in addition to, I don't think Rackspace are using the RDO Manager. Are there real-life deployments out there?
There are real-life deployments of it.
And for your use case, it's more so the security of the network. That's a big issue when you do bare metal deployment.
And we're working on this too.
Yeah,
And it's probably coming in Mitaka release.
because you need to configure the physical network this time to be able
And
to isolate.
Rackspace has this code downstream, and they're bringing upstream right now. Right as we talk, they're reviewing. Anything else? People are there for food? That's good. Thank you.